being recorded.
He is the director of the Iowa Flood Center, and Vitek joined the College of Engineering at the University of Iowa in 1987. So he's had a long and very successful career here. And today we've invited Vitek to talk to us about an upcoming field campaign that has some opportunities for student involvement and for adding some additional research interests and field work onto an extensive campaign that he's coordinating with the National Science Foundation and with NASA. And so with that, Vitek, I'll turn things over to you. Thank you for joining us, and we'll look forward to your talk.
Thank you. Thank you, Adam, and thank you, everybody who was able to join us, today. I asked to have this opportunity to share with you information and opportunities regarding a field campaign that NASA is organizing here in Iowa, and which the Iowa Flood Center is and my institute, IHR Hydroscience and Engineering, is hosting. So let's start with the big picture, and the big picture is really, really big. So it's a global, picture. So this field campaign is motivated by the needs of the Global Precipitation Measurement Satellite mission organized by NASA, but it's really a joint venture by many countries, and as you can see, many satellites. So it is about developing ability to provide global high-resolution precipitation estimates, variety of applications in climate, weather, and as you will see, hydrology as well. So it's quite impressive that NASA and other space agencies from around the world are developing this capability of providing rainfall maps on a global basis with high resolution, and by this I mean, let's say, 5 kilometers, and temporarily, let's just say 1 hour. And I say, let's say, because these numbers are, somewhat, approximate, because there is some interpolation, involved, as always in the case of using remote sensing. So that's really an impressive, capability. So then the question is, how good would those estimates be? The official start date for the mission is a year from now, February 2014. But to answer this question of how good these rainfall estimates should be expected to be, NASA has organized a number of field campaigns and other, studies to address, this question. So the strategy has been through field campaigns, many of which involve aircraft, ground-based arsenal of instrumentation to measure precipitation. Some of the recent, campaigns took place in Finland, and then in Oklahoma, and then more recently in Canada, just north of Toronto. And IFloodS here in Iowa is the first campaign that is motivated by the hydrologic issues, because this GPM mission is supposed to provide enhanced capabilities of hydrologic hazard, forecasting. So obviously we're talking about, floods and droughts and landslides worldwide, but also water resources, management. So it is very important that, NASA developers, as well as the user community, that we are all, convinced as to what the real capabilities are. So there are two key paradigms that IFloodS field campaign will be following. And the first one is with the goal of characterizing uncertainty that is involved not only in the satellite-based precipitation, but also in the entire, chain of instruments that are necessary to provide the answers. So we call it, bridging the scale gap. So as you all know, we trust, the water collected in little, buckets, because this is really the only, measurement that is directly relevant to rainfall on the ground. So that part of rainfall that has hydrologic significance. And so then how do you go from that scale of a single, bucket to a larger, scale of other instruments that have capabilities of measuring maybe scale of 100 meters, maybe to 10 kilometers, and then all the way to the national network of radars in the U.S., that's the NEXRAD network, and then all the way to satellites with global coverage. So that's one of the goals. The other, goal, of course, is to translate, that ability into ability of, predicting, floods. How well can we do this? What are the useful, scales, here? How does the skill change with scale? So those are all the questions that this campaign will try to answer. So you can see that NASA will bring an impressive arsenal of instrumentation that has the capability to provide observations of rainfall and precipitation in general, because GPM is not only about rainfall but also snowfall and other forms of precipitation. And it's not just the total amount that is of interest, but also the microphysics of precipitation, so the type and shape of precipitation, particles. And this is important not as much for applications, but more for the algorithm development. So the satellites look straight down and they see this vertical profile of different particles and how the phase, changes. And the algorithms, rely on understanding of two fundamental processes that happen, there, and that's scattering and emission. And so that's why knowing drop size distribution and more generally particle size distribution is as fundamental as the total amount or intensity. So NASA has committed to bring all these instruments to Iowa. And again, the second goal will be to see how well, with excellent rainfall observations, one can do predicting floods, and then having this very high resolution and high accuracy reference, data set, one can then downgrade the resolution and accuracy, all the way to what is expected that will be the capability from space, and then see how that affects flood, prediction. So those are the key, goals, here. So NASA is bringing all this instrumentation to northeastern quadrant of Iowa. So that's still a good, chunk of real estate. So roughly 50,000 square kilometers. I'm showing, here the location of the main asset that NASA is bringing. That's a Nest-band radar, polarimetric radar. So a radar with similar capabilities to the NEXRAD radars that we are all, familiar with that difference that operators can do whatever they want, with it. Unlike with the operational, radars that by law are supposed to scan in a certain, way. What I'm also, showing here are the 150 kilometer range marks from the operational radars located in Davenport, Iowa, La Crosse, Wisconsin. This one is near Minneapolis, and this one is in Des Moines. And you can see that although we know that NEXRAD radars have longer range, 230 kilometers, that's the range of operational, products, but at that range, the quality of estimates deteriorates. And so if you limit yourself to 150 kilometers, then there is a little bit of a gap, and this NASA radar will, this gap. So you can also see a number of watersheds, here. And of course, there are more. I only mark, a few just for your, orientation. Some of you may remember that just a short 5 years ago, there was a catastrophic, extreme, flood here in Cedar Rapids, Iowa, and also on our campus here in Iowa City. So now, just for your, orientation. There is an experimental watershed that is of interest to ARS, and in this watershed there are observations, in situ observations of soil moisture, and that is of interest to another satellite, mission, SMAP, soil moisture active initiative, which is scheduled to launch in 2015. And in this experiment here in Iowa, the two missions, they are beginning, to talk to each other, and that's very happy news for all of us in hydrology. There is another, smaller watershed, which is, I call it, a playground for a team here at the University of Iowa, and this is part of a recent, proposal to become a critical zone observatory. Together with the team from University of Illinois. Looks like we lost, connection. At least I cannot see the image. So I will.
I see the image, Vitek.
Oh. Well.
But it's the one with Davenport. It's the range.
I lost, that. Whole image.
But I can advance the slide if you want me to.
Okay, yeah. Why don't you advance, the slide then,
And we're seeing the mobile radar. The little inset comes up.
Yeah. Right. So. Okay. So how about just give me just 1 second. What to do? I have the presentation I provided. I have it right here on my desktop, so I can follow that way, and so that I will know which slide is next. Okay, so this is the domain. This is where it will all happen. And now, why Iowa? Well, because we do get floods. Also because we don't have the complications that the space algorithm developers may not like, complications such as snow on the ground, orographic enhancements, coastal lines, on and on and on. So we have a fairly uniform landscape here. But we do get, floods, we do get, rainfall. So this is like a good, testing, ground. So if we can do well, here, that would give a boost of confidence to the algorithm, developers and all the users, and then we can move on to other places that do have those complications. So that's kind of the general, plan. So again, this is the first hydrologically motivated, campaign. But there are others in different planning, stages. So now, another advantage of coming, to Iowa is that following that big flood of 2008, the state established the Iowa Flood Center and asked us, to help. gave us some money. And with that money, we have improved the flood and stream flow monitoring infrastructure, among many other things. So we have installed some 130 and counting stream sensors throughout the state. So essentially doubling the number of stream gauging here in the state. So of course the other set of gauges are those operated by USGS. So we have many of those, many on smaller streams and rivers. Also because of our research in rainfall, so I'm now on slide number 8, we have developed and used here a number of rain gauges. So we have locally dense networks, and in fact I'm proud to say that we are provider of rain gauge networks for NASA. We provided one that is now located on the east coast, and this is like a central validation facility for GPM and other rainfall studies conducted by NASA. And we are now in the process of building another one. So now I'm showing that slide that has a crosscut through the ground, showing a combination of a rain gauge with soil moisture station, and again everything connected via a cell phone modem and reporting data in real time. So we are building 25 such stations for NASA. They will be deployed first here in Iowa, and then they will move them somewhere else. Moving on to the next slide, we expect to have several of vertically pointing radars that will provide data on the vertical structure of precipitation, and this is clearly very useful for the algorithm developers, as I mentioned before. You can see here from this.
Vitek, I'm sorry, you're not giving me the slide advance indication. So right now I'm looking at the slide with the multiple rain gauges on it.
Oh, so you are behind.
Do you want the next with the profiles?
Well, so if you go slowly to the next one is that rain gauge soil moisture.
So I soil moisture active passive SMAP NASA.
Right. Okay. So we are building and we are going to deploy for IFloodS 25 of those in one of the bases, and then these instruments after the experiment will be moved somewhere else. I don't know exactly where. And then moving to the next slide, which shows this colorful vertical structure of precipitation. Are you there?
Yes, I'm there.
All right. So,
and the animation is going.
Right, great. So there will be several of radars that will be capable of providing these kind of images. And so this will provide a very rich rainfall context. And then moving on to the next slide. This shows the main sampling scheme designed for the experiment, and this sampling scheme will explore the range effect. So ground-based radar range effect. So this is something fundamentally important to understand how well radars can observe precipitation, and precipitation again not only from the point of view of intensity or total rainfall, but also from its ability to provide information on particle size distribution. So rainfall drop size distribution and different types of precipitation, and delineating where clouds begin or where there is ice in the clouds and where the ice is melting and so on. So exploring that ability is fundamentally important, not only for NASA, but also we are hoping to learn and take advantage of this for the operational network of radars, because again, as you remember from an earlier slide, there are at least 4 NEXRAD radars that are looking over the same area. So let's move on to the next slide, which shows the general schedule for this experiment. So you can see that nominal starting date of April 1 is just around the corner. The plan was to have all the instruments that I was showing you earlier deployed in the field. Well, it's still pretty cold, here in Iowa. The ground is frozen. It's not very convenient, to say the least, to install instrumentation in weather like this. So we hope that between now and April 1 there will be a warming, and we'll be able to start deployment at the end of March and continuing into the beginning of April. But we estimate with our NASA colleagues that it should take a week to 10 days to deploy all the instrumentation. There are quite a few of those. What you may call intensive observing period will be here starting on May 1, and this is the six-week period when that main NASA radar will be here. So they will bring it to Iowa in mid-April, but it takes about 2 weeks to put it together after transporting it across the country. Then it will operate, here for 6 weeks, and then again it will take a couple of weeks to take it apart and ship it, back. And so, well, I just hope that it will rain during the 6-week period that this radar will be here. In fact, in the previous, slide, I was showing you another smaller radar, which will be co-located with the big one, and this smaller radar, its claim to fame is because it will have exactly the same operating frequencies as a radar on board of the GPM satellite. And so this will be an opportunity to NASA colleagues to look at the issues of detecting and characterizing precipitation through the same eyes, you can say, as those that will be looking down from space. Now, during the experiment, we will be doing weather forecasting. This is for the purposes of operational activities, but also to support the adventurous hydrologists. So this is what's going on. NASA, they have set up WRF, the Weather Research Forecasting model, that will run on a NASA supercomputer, and it will provide 2 days ahead very detailed precipitation forecasts. And so with 1 kilometer resolution, and with some products having temporary resolution of 5 minutes. So this is really a formidable task, and they will do this forecasting for that Iowa domain. So the implications of this are that one can try improved stream flow forecasting. So relying not only on the observed rainfall that already happened, but also looking up to 2 days ahead. And our colleague from Iowa State University, Professor Bill Gallus, in atmospheric sciences, he will be giving daily briefings. And he will be followed by a hydrologist from
listen to webinar. Yeah.
From the River Forecast Center in Minneapolis, who will be giving daily hydrologic briefings. Even though in this experiment there is no strong requirement for all the participants to be here in Iowa all the time, So the activities will be in some sense, distributed and virtual, but nevertheless there will be this regular, presence and daily activities. Now, let's move on to the next, slide.
The IFC Radar-Rainfall Products?
Yes.
Okay.
So in anticipation of engagement by hydrologists, we have developed like a database of some popular radar-based rainfall, products that some of you may be interested in using in setting up your models. Some of those products are well known, like Stage 4, product, but then there are other higher resolution, products that either we here developed or are available from other outfits. But it will be all about, Iowa, rainfall in Iowa. Also, there will be 4 of University of Iowa X-band polarimetric radars participating, and again, many of you may have heard me and others talking about, these radars because they are a resource available to the broader hydrologic, community. In fact, a couple of years ago, we brought one to a quasi symposium in Boulder, and so you could, touch it and, were able to discuss it, the potential, use. So, but this is really the first serious test for these radars. So we are looking forward to their deployment in this experiment. Now, my biggest, hope is that this whole experiment, because it's so much, focused on rainfall as well as rainfall applications to flood forecasting, that it will be of interest to a number of you, especially those who are involved in hydrologic, modeling. So just to talk about hydrologic modeling, let's look at the next, slide, which shows Iowa, landscape and generic some hydrologic, model. So here is how I look at, things. So in hydrologic, community, we don't have this, culture of, venturing and making real-time stream flow, forecasts. Our journals, though, are full of modeling, results, simulation, results, and many of those look really, really good. And so this is an opportunity to see how they will do in real-time environment. Now, it's not a requirement, but those of you who are adventurous, enough and whose models can be set up, quickly, can do this because there will be excellent rainfall, resources, available. Now, those who are less adventurous but nevertheless still interested in this, topic of developing and testing and improving hydrologic, models, or in specifically rainfall runoff, models, well, there will be plenty of opportunities after the experiment. So, of course, all the data will be processed, quality controlled, and made available to a broader, community. So, but my personal hope here is that we will get at least, a couple of, groups who will try to compete, and I don't want to, overuse, this term, but I'm saying this with a smile. To compete with the National Weather Service because it is the River Forecast Center in Minneapolis that has the responsibility for making routine, systematic, 4 times a day stream flow forecasts for this area. And so, and of course, they have models. These models are well calibrated, you know. So if you can beat their models, then that's a big deal, and they would love to hear from you. So, so that's this sounds like a challenge, you know. It is. So now, clearly, one can look at this whole experiment much broader than just from the perspective of NASA algorithm, you know, development and testing capabilities for these flood forecasting applications. One can put it like this: that any study, any hydrologic study that requires a good rainfall, you know, context at a scale that is larger than, let's say, just to use the number, 1 kilometer, you know, scale, could potentially benefit from the data that will be, you know, collected, you know, here. Also, because we don't have many such experiments in hydrology, this is an opportunity for creating, you know, bonds and for sending, you know, your students and showing them, you know, how it's, you know, done, and taking a closer look at these instruments that will be all over, you know, the place. And so with this, and maybe collecting, you know, data that are at first, you know, glance, not that relevant to the goals of NASA and the GPM, you know, mission. And I'll show you in the next, you know, slide, you know, a couple of examples, you know, like this. But again, this is a broader way of thinking about this experiment. Anything that can potentially benefit from good rainfall, you know, context at a larger spatial, you know, scale, and that doesn't require 50 years of data, can benefit from this experiment. And with this in mind, I wrote a very short proposal to NSF, and so we are moving now to the next, you know, slide. And I got a rapid, you know, grant, and this grant is, you know, specifically to support people who are not funded by NASA. And so, so the idea here is that if there are people who can send an instrument or a student or both, or who would like to take, you know, some time and maybe set up a model here using, you know, the data from IFloodS, we can provide some, you know, financial, you know, support. Not a lot of money, little money for shipping the instruments, for travel, for, you know, a week here, you know, in Iowa, or a little, you know, stipend for a student, you know, something like this. And here is a list of people who already committed, except for Jeff. Jeff, I talked to Jeff, but I have to confirm, you know, his participation, you know, with him. But all others are have confirmed their participation. The list includes also some, you know, modelers, both, you know, Fred Ogden and Chris Duffy, as well as Pedro Restrepo, who represents the National Weather Service, and some colleagues at USGS. They are very excited about, you know, this. And also the GPM hydrology group involves several people whose names I'm sure you heard, you know, before. And so I'm talking about, you know, Rafael Brass and Eric Wood and Dennis Lettenmeyer and Effie Fufula Georgiou and Anna Barros, and you know, and the list goes on and on. So so this is what's shaping up. If you are interested in participating and you don't have your own you know, money to send a student, well, this is what you could or should do. just send me a short, email. Tell me how you think you could be or would like to be involved. Give me some idea about, the cost because this rapid, grant is limited. So I cannot promise everybody thousands and thousands of dollars. But if you send me an email, like this, then we can continue the dialogue and come to some agreement that I believe will benefit everybody. Now, before you do this, you don't have to just rely on what you just heard from me. I would like, before you make a decision, to explore some of the links that I'm providing here. And so actually it's an easy way to get to all of those. You can just Google Iowa Flood Center and you will get to our main website. So, but that's just like another, website. But there is some information, there about our activities and who we are and what we do. Then the key kind of our window to the world, but the world is limited, to Iowa, is what we call Iowa Flood Information System. So this is this IFloodS, which provides in real time hydrometeorological, conditions for the Iowa, community. But it's a cool system, so it can show you the domain, it can show you the geography because everything happens there within the Google Map environment, names of places, and so forth. The next link builds on this, and it is a link to what we call a planning resource. So this is again a website within a Google Map, framework that shows all the locations of all the instruments that will be deployed here during IFloodS. So no data, just the locations, but locations of instruments in the context, the local context. So the basins and the range of radars, and there is a whole bunch of different layers that you can turn on and off, and that's why I just really couldn't present it here because there is just too much, but you can easily browse it and kind of figure out what's going on and use that as another basis for making a decision about your potential participation. Of course, you can also just either call me or write me an email. I'll be very very happy to chat with you and tell you what I couldn't tell you today. Now, for the campaign, NASA is setting up a portal. I believe that the draft already exists. So this is, again, a typical way of how NASA supports these field campaigns. So there is a portal. It's a password, protected, portal, but you can self, register. And in that portal, there is, all the campaign-related, news, facilities to upload, data, and if not data, then perhaps, images as things, happen. Weather briefings and just everything that is relevant to the campaign. But it is organized in such a way that is relevant to the technical people. So all of us. Unlike IFloodS, which is designed for general public of the state of Iowa. So again, if you cannot or don't want to, participate, you can still watch what's going on by following the information provided by that, portal. So with this, I will stop. Here in Iowa, we are, ready, kind of, and I hope that many of you will join us. Thank you very much.
Thanks, Vitek. Adam, are you on?
Yep, I'm here, Rick.
Okay, thanks.
So the folks on the line, first thank you very much, VTech, for a great talk and for giving everybody a sense of both the background and origin of why this project is happening, as well as giving us a sense of ways that we can all participate. So for folks on the line with questions, let's see, if you want to either unmute and ask those questions, or if you want to type them into the chat box, we'll ask VTech to just address them in the order they come in.
By the way, I do not see the chat box, so somebody will have to read the question.
Well, I'll try to read them to you, VTech, if people choose to do that instead of just unmuting their phones.
Okay.
And while we're waiting for folks to have questions potentially come in, I'll just remind you again that Rick is recording this presentation, and so hopefully this afternoon or early next week, the folks at Quasi will get this posted online so that you can go back to find these resources, hear what VTech is saying one more time, and also share this with other colleagues at your university or that you think might have a student interested.
And I will just add that even though there is this nominal, period, and with the starting, date just around the corner, April 1, one can join at any, time, even after, the experiment, as I was, saying. So the participation here by our Quasi, community can be defined in many ways, and it's a very, flexible, context. So don't think that you are too late.
I see that Sue Liang is typing for quite a long time. Sue, you could just unmute the talk as well.
Sorry. And thank you very much, VTech, for a very interesting talk. My question is, what kind of data access to or protocols like HTTP or GDS or OpenDAP, for example, or web service is used for access or retrieving the data from the IFloodS network?
Yeah, so the answer depends on the product, but we, the Iowa Flood Center, will provide a basic, rainfall product, which is actually a high-resolution rainfall rate, field every 5 minutes with resolution that is, sub 1 kilometer, that one can see in IFIS. So we have organized a web service for that, product, and anybody who wants this can have it. Now, this product is radar-only product, so it will not take advantage of all this other, data. So that will be done after, the experiment. Also, the data that the NASA radars will be collecting, unfortunately, because of the limitations in the bandwidth, it's unlikely that they will be providing them in real time. They will be providing some, images. So one can always look at what they saw and use that, as a context. And only after the experiment they will process all the data and develop what one may refer to as, the best final, product, whatever, that is. So unfortunately, this will not be done, in real time.
But the radar data is in the web service format, right? Will be.
Yeah. So IFIS, data is based on 4 NEXRAD, radars that look over Iowa or that part of the state. So yeah, that will be provided, and that's high resolution, good product, as far as so one can use that, definitely. And so, yes, that's a web service. And similarly, through also a web service, we already provide the stream gauge, data from those sensors that we install, those bridge sensors that them. So we already have a web service, and that's been in operation for a while because we provide the data to the National Weather Service and the USGS. So again, we can provide information about, that. And then, of course, the other set of data is the USGS, data. So you know how to get that.
Yeah.
So
those bridge sensors are already in the network sense and provided through the web services, right?
Yes. Yes.
I see.
Yeah. So that's done, and we'll be only adding. So as few more as the weather permits. But there are quite a few already.
I see.
And so one can say that now also the soil moisture data will also be provided in real time. So so here the delay is because of the weather, specifically because of the frozen. So I don't know when we'll be able to dig to 2 or 3 feet. So. So we'll see, but the moment we install the sensors, we push a button and the data come in real time.
Okay, great. Thank you very much, Witold.
And is there anybody else out there with a question for Witold? You can feel free to unmute yourself or go ahead and type them into the chat box. Okay, well, Witold, I think that's what we have from the audience today then. So we will, as I said, we'll get this posted, and Krajewski will send out a link to let folks in the community know when we have this recording of this posted online.
It'll be next week, yes.
And hopefully somebody out there has, you've triggered some interest to get some more folks to come visit us here in scenic Iowa.
Well, I hope so. So thank you again, everybody.
Okay.